My Cool-It Project by me on November 25th, 2013. We are learning about exponential relationships, especially exponential decay. This experiment, we were looking for the exponential decay for the temperature of boiling water after each 5 minutes. So, how did we do it? Well, first we connected a thermometer with an app on the calculator to graph the temperature each minute. We poured boiling hot water in the beaker where the thermometer is connected and waited for 45 minutes so the thermometer could graph and record the data after each minute, for each minute. A table can show us many things. The two most important things that a table can show us is what the initial condition is and what the rate of change is. Well, what is the initial condition on this table? Well, this table, first of all, you need to understand what an initial condition is. The initial condition is just another name for the y-intercept, or the starting value. And that is when x is equal to 0. So in this table, when x is equal to 0, the value is 88.29175. This means that our initial condition is 88.29175. The table is a really easy and quick way to find using the table is an easy way to find the initial condition because it's really easy and straightforward. As I said before, the table shows us many things. But two main things that the table shows us is what the initial condition is and what the rate of change is. Well, we said that the initial condition is 88.29175 because that's the starting value after 0 minutes. Well, now, what is the rate of change? Well, the rate of change is just another name for the unit rate or the slope. And all of us know that a unit rate or slope is per minute, not per 5 minutes. And this table shows us the data per 5 minutes, which is not helpful to us. Well, we can see that the values is decaying exponentially. So we know that the rate of change will be 0 point something because it's decaying exponentially. Well, something that I forgot to add in this table is after 1 minute, how many what will the temperature be of the boiling water, which I should have added to my table, but I didn't. Well, this is a very necessary part for us. This is a very necessary piece of data for us because this will help us find what the rate of change is. And so the temperature after 1 minute was 85.643. So all we have to do now is just divide 1 minute by the starting value or the initial condition. So that would be 85.643 divided by our starting value, which is 88.29175. Well, the answer to that is 0.96. But since we're not in perfect math world, it's not decaying exponentially at one specific rate. It's decaying exponentially at many different rates for each point, but they should be really similar. So if you look at the data per minute and divide most of the numbers, we'll get an average of 0.97. So we can see that 0.97 is our rate of change. Because much like a table, the graph shows us many things. The two most important things that a graph shows us is the initial condition, what it is, and what the rate of change is. Much like a table. Well, the initial condition is really easy to spot on the graph if you know how to. Well, remember, the initial condition is just another term for the y-intercept or the starting value. Well, the initial condition is really easy to spot because all we have to do is look at this line. Well, this line goes up by 20, 40, 60, 80. It goes up to 80. But if you look closely, which the graph is zoomed out so you won't be able to, you can see that this point is at 88.29175. Well, this is our initial condition because, as I said before, the initial condition is when x is equal to 0. And so then this line is where x equals 0. X equals 0 on this line. Well, we can see, we just have to look for the point, and we see that it's on 88.29175. So this tells us that the initial condition is 88.29175. This graph also shows us what the rate of change is. We can see from this graph that the values are decreasing. Let me write that down. Decreasing at a decreasing rate, because the line is shaping as a slope and is evening out towards the end. This is also exponential decay. If you look at 2 points of these 2 points in this graph and divide them by each other, you will get somewhere around 0.97. Because we're not in perfect math world, we're in real life situation. You will get 0.97, and this shows that the rate of change is 0.97. You can see that the line is not perfectly on the dots, on the points, because there is no one rate of change. It's around 0.97, and it'll keep on changing for different amount of points, but it's around 0.97. So this line is what I think very accurate. And this shows that the rate of change is 0.97. This is the equation that I came up with for our experiment. The initial condition is 88.29175. I know this from previous knowledge, and also because usually the initial condition comes first in the equation, and then the rate of change would come second with the exponent on top. And also, we can see that this is the initial condition because we know that the rate of change will always have an exponent on top of it to show how many to show the variable of how many per how many minutes. We also know that the rate of change is the number with the parentheses on top, with the exponent on top of it. And so in this case, we know that the rate of change is 0.9. This experiment really helped me learn how to use what I'm currently learning in math class to real life situations. We are currently learning about exponential relationships and exponential decay. Before, I felt really confident about exponential relationships and exponential decay, but I didn't see how it mattered in real life. But now I actually see how it mattered in real life, and this helps me think that each math concept that we learn in class is really important. I also learned that once you boil water in, once you measure the temperature of boiling water, it will eventually decrease at a decreasing rate. I'd like to thank all of you who've taken the time to watch my video. Thank you so much. We appreciate you.